Now that we're loaded in our Cessna 172 and X-Plane 10, we demonstrate the control surfaces, starting with the ailerons, then the elevators, back to the ailerons, and the elevator once again. We then add 1 notch of flaps for takeoff and increased thrust. We continue our climb to a stabilized altitude of 1500 feet. We have an airspeed of just under 80 knots, and now we begin our climb, pitching the nose up, which increases vertical speed, results in airspeed loss, and also increases our altitude. We now level the wings back off, pitch the nose down, increases vertical speed, decreases altitude, and as a result airspeed increases. And then finally, the purpose of lesson 1 FlyToLearn was to understand the concepts of how the control surfaces work, what effects they have on the aircraft, and that by not adjusting any sort of throttle, that pitching the nose up of the aircraft causes a decrease in airspeed, an increase in altitude, and vice versa when pitching down nose. First of all, we'll be conducting a test of 296 pound payload weight. We had a range of takeoff lengths from 1,621 feet to 1,714 feet. We then moved on to our 600 pound payload weight. Here we had a range of takeoff lengths from 1,827 feet to 2,465 feet. And eventually then we did a 900 pound payload weight test, where we had a takeoff range of 2,834 feet to 3,594 feet, by far the most longest takeoff distance. The purpose of lesson 2 is to provide a key understanding of how weight affects an aircraft and how payload weight and aircraft weight can affect the overall takeoff distance necessary to become airborne. Here we are loaded into our Cessna 172 for lesson 3. As you can see, we have turned on the lift vectors to demonstrate the lift components across the wings. We are now going to increase the angle of attack, which will cause the airspeed to decrease. And I'm quickly going to pause it here so that we can see the decrease of lift across the wings. And I will now unpause it, and you can see quickly that on the left wing, lift dramatically decreases, causing the aircraft to go into a stall. And here we are recovering by putting the aircraft into a nose down dive to increase airspeed. And you can see here again in that replay that there was a dramatic decrease in lift on the left hand side. We now move on to lesson 4. In lesson 4 we will now deploy the landing gear to demonstrate the drag component of the landing gear. I've now sped up the video, but as you can see, the aircraft's airspeed continuously decreases after I've deployed landing gear. And here now we're going to display the flaps. So we're going to engage full flaps, and as you can see, sped up video again, the airspeed continues to decrease down to a steady 80 knots. The purpose of lesson 3 and 4 was to demonstrate the drag components of the aircraft, and that external features such as the landing gear or the deployed flaps increases the drag and also the lift on the aircraft in the case of flaps. We are now loaded into our Cessna 172. We are on the final approach path, and for this approach we will not be utilising flaps and will be depending solely on the throttle control. So we have now set our engine RPM to 1600 RPM, and by monitoring the PAPI system, also known as the Precision Approach Path Indicator, we can land the plane perfectly at the right touchdown zone. By remembering that all red lights would indicate a too low approach and all white would indicate a too high approach, we can utilize this to touch down perfectly at the right zone. For this approach that we are seeing now, we are utilizing flaps, and you can see airspeed is greatly affected with a much slower approach and a higher RPM for the engine to maintain that. And finally, we have some carrier landings with different landing conditions. Remembering that the purpose of lesson 5 was to understand how flaps can affect the landing, that by utilizing throttle control you can control an aircraft's airspeed during the descent and during the approach phase, and also by utilizing the PAPI system you can land the aircraft at the correct point of the runway, remembering that for an optimal landing, 2 red, 2 white, all red lights you're too low, and all white lights you are too high. We are now loaded into our Cessna 172 and are now demonstrating the lift forces upon the wings of the aircraft. We slowly ascend to demonstrate the increase of lift before quickly descending to show the decrease. We now place the centre of gravity fully aft and put the payload weight to the maximum. As you can see, in order to maintain steady flight, we have to pull back on the stick quite dramatically. We now place the centre of gravity fully forward on the aircraft and also place the payload weight at maximum. Here again we can see this aircraft is quite unstable and it's quite hard to fly. We also have to keep the nose in an upright position in order to maintain level and steady flight. Then finally, the purpose of lesson 6 was to demonstrate how the aircraft's centre of gravity and the payload weight placed at different points on the aircraft can affect the flight stability and overall performance of the flight of the aircraft. For the entirety of lesson 7, we'll be using a custom RV-10 aircraft with custom wing sizes, wingspan, aspect ratio and mean chord length in order to demonstrate the differences that these wing sizes can have on the aircraft's ability to take off. In this video, we will start off with a wingspan of 10. This is 10 foot. As you can see, the aircraft has significant difficulty trying to get airborne until certain airspeed is reached. Wingspan 20, not so much, with an easier takeoff. Wingspan 30, with an even less takeoff distance required. Wingspan 40, yet again an even shorter takeoff distance. And then wingspan 50, with an average takeoff distance of only 331 feet. The purpose of lesson 7 was to demonstrate that how the wingspan can have an effect on the aircraft's takeoff performance, and to understand the key concepts surrounding aspect ratio and mean chord length. We are now loaded into our RV-10 aircraft and are ready for takeoff. First of all, we will be taking off with a wingspan of 15 feet. As you can see, we use up roughly 3/4 of the runway before we become airborne. Second, then, we had a wingspan of 30 feet. This, you could see considerably less runway needed for takeoff, at only half the runway being utilised. And it also must be noted that the gravitational values were modified for this takeoff as a result of the total weight being 10,000 pounds. The purpose of lesson 8 was to demonstrate the wing loading upon an aircraft, to calculate the wing loading using different chord lengths and different wingspan lengths. For lesson 9, we are now loaded into one of our 3 custom RV-10s, each with a different horsepower rating. We are now going to take off with our 150 horsepower engine and will begin a cruise flight of 3 minutes. I've then attached a screenshot of the value of our final airspeed after 3 minutes. We then moved on to our 300 horsepower engine. Again, cruised for 3 minutes and attached a screenshot showing the final velocity after 3 minutes of cruise. And then finally our 600 horsepower engine. We cruised for 3 minutes and I've now attached a screenshot of the max V that was achieved. The purpose of lesson 9 was to demonstrate how the different horsepower engines can affect the flight of an aircraft, the velocity of an aircraft, and how the weight to power ratio can affect the performance of an aircraft.